Hi everyone, this is Miss Graham, and today we're going to be looking at Lesson 11.3, Proving and Applying the Congruence Criteria. So go ahead and pull out pages 154 through 159. We're actually going to be skipping a couple pages in between because we're really going to be focusing in on understanding how we can go from one idea to another. And just giving you a heads up, we are going to be doing proofs. So we're going to save that kind of for the end of the lesson, but let's go ahead and start looking at our learning targets. Our learning targets for today are that we are going to prove, let me pull out the highlighter, we're going to prove the congruence criteria that follows from the definition of congruence, and we're going to use the congruence criteria in simple proofs. So below it says you can use SAS, SSS, or ASA congruence criteria as shortcuts to show that two triangles are congruent. In order to prove why this criteria works, you must show that they follow the definition of congruence in terms of rigid motions. So number one says to justify the SSS, which remember what that means, right? That's side, side, side congruence criterion. Consider the two triangles below. A says what given information is marked in the figure. Well, we can easily see that AB is going to be congruent to DE. So we're going to go ahead and write that down. So AD is congruent to DE. Be careful. Remember how I'm saying which letter goes first when I'm looking at different segments. We also know that AC is congruent to DF. So I'm also going to say AC, line segment AC, is congruent to DF. And then last but not least, we have the three tick marks. We know those go together. We're going to say CB is congruent to FE. Now it says, based on the definition of congruence, what do you need to do in order to show that triangle ABC is congruent to triangle DEF? Well, we know from our definition of congruence, right, that if we're able to put one figure on top of the other one, we're able to map, triangle ABC to triangle DEF through a sequence of rigid motions, then we'd be able to show that they are congruent. So that's what we're going to say. We're going to answer by saying that, highlighter again, we need to show there is a sequence of rigid motions that maps triangle ABC onto triangle DEF. So now let's look at part C and what that says. It says it is given that ABC is congruent to DEF. So let's say that's what's given. What does this tell you? Well, it shows there is a sequence of rigid motions that maps AB onto DE. So we're going to say it shows that there is a sequence of rigid motions that maps AB onto DE. Let's continue on to part D. It says draw a figure to show the result of the sequence of rigid motions that maps AB to DE. It says assume that the sequence of rigid motions does not map point C to point F. So looking up at our picture above, we can't just put our exact same figures on top of each other, right? That wouldn't work necessarily. That wouldn't exactly, map it in some way. And we also have to make sure point C is not on top of point F. So we can't have these 2 points on top of each other. So maybe what I'm thinking is let's start off by drawing our triangle EFD kind of in its same location, in its same spot. So I have E, F, and D. So go ahead and put the spots there. We know this is going to be our side that has the 3 tick marks, the 1 tick mark, and the 2 tick marks. You don't necessarily have to put them there though, but it just kind of helps us visualize. So we want to draw a figure to show the results of a sequence of rigid motions that maps AB to DE. So somehow we want to figure out how to get AB and DE on top of each other. But, you know, we can't have CF. And like I said, we want to assume that this is a sequence of rigid motions that does not map point C to point F. So keeping this in mind, couldn't we think of this maybe as some type of reflection? Couldn't I think of maybe having my triangle ABC kind of below it so that, again, I want to make sure that, yes, I do have point E, and yes, I do have point D right there, but I want to make sure I also have point B and point A in those spots. So the best way to think about it is to think if this segment here also represents BA or AB. So then when we draw that, isn't it going to look something like this, where this is point C? This follows our rules because we know point F and point C, they're not on top of each other. And I did follow my rules. I drew a figure that shows the results of some sequence of rigid motions, right? We could do translations, rotations, reflections, and it maps AB onto DE in that exact same order. So I like that picture. It's looking really good. We can kind of see that we have AB on top of DE. So let's go ahead and let's look at part E and see what it's asking us to do right there. It says, which points coincide? Remember, that means on top of each other. If you don't know what that word means, I'm helping you out. It means which points are on top of each other in our drawing. So let's start with that. Well, obviously we know A and D, so points A and D. We also know points B and E are on top of each other. But also think about this. It asks which segments coincide. Well, we know that was exactly what we were asked for. AB and DE. All right, let's go ahead and look at our last question. It says, mark the line segments that you know are congruent in the figure below. All right, well, it kind of looks similar to what we did above, except now it just has this kind of dashed line through it to represent something else we're probably going to look at. Think about what we had before and what our perspective markings were. We knew exactly that these two lines that were on top of each other are congruent. So sometimes we can mark those, sometimes we don't. Sometimes people put like 1 tick mark. Sometimes people put like this S symbol to represent that it's the same line that's congruent with itself on top of each other. But we also know that these two are congruent to each other, right? DF and AC. And we also know EF and BC are congruent to each other. I don't have to put the 3 tick marks there because essentially we don't have a 1 tick marker. So I'm going to put EF is congruent to BC right there. And then let's go ahead and go on to our next page. We're still going to be building off of the problem number 1. I know there's a lot of parts to it, and we might have to kind of flip back and forth, think about what we're going to be doing. Or maybe what I could do is I could kind of copy and paste the figure off to the side here, and we could reference it for help. So I got it pasted over here, and now it says, okay, based on our figure. All right, so based on our figure, how is ED related to FC? Well, kind of looking at this picture, doesn't this look like it creates a 90-degree angle? So doesn't it look like ED is perpendicular? So it looks like ED is perpendicular to FC. But here's something else that we're also going to notice, right? ED actually cuts FC exactly in half. So there's a word for that. There's a word for that. That's called bisect. So we're going to say ED is the perpendicular bisector of FC. Since, we're going to say since point E is equidistant, since point E is equidistant from F and C. So think about it. Point E, I mean, I could have said it was point B, but it's the same distance from F and C, right? We know it with those congruence tick marks. So we know that these are also going to be congruent to each other as well. Interesting. All right, let's keep going. Let's go ahead and we are going to look at H. It says, consider the reflection of triangle ABC across ED. What is the image of ABC? And how do we know? Well, this one is actually very interesting. So it says, we're looking at and we're saying that the image of ABC, we know it's going to be triangle DEF. Since points A and B, they're fixed under our reflection, right? Since they are on the line of reflection. So we're going to answer this by saying the image of triangle ABC across, right, this kind of line of reflection, ED, right, is triangle DF. Since points A and B are fixed under the reflection. And we're going to also say, since they are on the, and I'm just going to say line of reflection, I'm going to abbreviate that right there. So they're on it. So something to kind of keep in mind. Now something that I skipped over before that I definitely want to point out in the margin, kind of over here, you'll be able to see it in your textbook, is that the perpendicular bisector theorem. It states that a point lies on the perpendicular bisector of a line segment if and only if it is equidistant from the endpoints of a segment, which is exactly what we answered in part G. So that's a good idea of where I got this idea of, point E being equidistant from F and C. What we're going to do now is we are actually going to skip the rest of this page. And what we're also going to do is we are going to skip pages 156 and 157. So you can go ahead and skip those pages. We're going to go ahead and start looking at page 158. All right, so we're on 158. Let's go ahead and look up at the top. Now, even though we didn't go through this problem, we're saying that there is a sequence of rigid motions that can map a triangle onto each other. That's what we saw in our first problem, and that's what it continued to show on in the rest of the problems. Specifically, the sequence of rigid motions that maps AB onto DE, followed by a reflection across ED, it maps triangle ABC to triangle DEF. By the definition of congruence, we were able to see that triangle ABC was congruent to triangle DEF. Now we can use the SSS, SAS, or ASA congruence criteria to prove that triangles are congruent. Before, we just focused on side, 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 but the other two pages, what we skipped, they showed other examples of side, angle, side, as well as angle, side, angle. So what's really important for us to do is to kind of practice thinking about these in the ways of a proof, how we're given one thought and how we're able to jump to the next. So we're going to look at example A together. We're going to go back to this idea of Greg and his triangular trusses, right? We looked at that from 11, 1 and 2. So it says Greg knows that point X is the midpoint of JK in the truss shown below. All right. He also makes measurements and finds that JL is congruent to KL, he must prove to his boss that triangle JXL is congruent to triangle KXL. So what I'm going to do in the future is I'm going to use the margin to kind of write out a proof. If you need some extra space and you want to do it on a different sheet of paper, you can as well. But for our proof here, what's really nice is it's already done for us. We're just going to walk through and look at how Greg was able to come up with this and start thinking in this type of mindset. So let's start looking at the given. So we have two pieces of given information. We talked about how we can focus on either one. We can do both of them at the same time, or we can have an initial given and then space out the other one throughout the problem. We can see Greg here started off with that first given, that x is the midpoint of JK. So we know that's our given piece of information. Something next that we know is that if x is the midpoint of JK, then that means JX will be congruent to KX. Remember, that goes back to definition of midpoint. So sometimes what I like to do is I like to mark on my figure as I go along with each of the proof statements and reasons. I would really suggest you do that too. So since x is the midpoint of JK and we proved that JX is congruent to KX, I'm going to put a congruence tick mark on each of those so I can show that those are congruent. Now, the next thing that he jumps to is our next given. JL is congruent to KL. So it is a given, but what's also important is that we make that marking on our picture as well. JL, and I'm going to use two tick marks, so it's different from JX and KX. So JL is congruent to KL. All right. Now, this is the part what we're working towards. We're going to try to show that the two triangles are congruent. So think back to the ways that we know how to prove that triangles are congruent, right? Think back to those ways. We talked about side, side, side. So I'm going to start writing these down. We talked about side, side, side. We talked about side, angle, side. We talked about angle, side, angle so far this unit. And we are going to have a couple more that we definitely are going to look at. But from our information here, we know we have two sides. So we're probably not going to look at angle, side, angle. So what would be the next piece of information that you think we have from this picture that we could prove? Ah, I see you. You're starting to see that LX is the same shared side. So these, oops, that's a really bad self-congruent symbol, but we can see that LX is congruent to XL. Now, they say it's through congruence as reflective. What I like to say instead, and I actually encourage you to do, is to say the reflexive property. That means that LX is congruent to LX, or you could say LX is congruent to XL. Either way works. We know that's our reflexive property. So therefore, looking at all of this, right, drum roll, we can see that, we know that the two triangles, right, the two triangles, triangle JXL and triangle KXL, are going to be congruent through side, side, side. So that's something that, we worked through how to do a proof. We started off with some givens. We had to think about the picture as a whole, labeling what we knew along the way, what our next train of thought would be. And then we had to think back to, how do I prove that triangles are congruent? Well, we have to know some pieces of information for that. And we focused on side, side, side this time around. So what we're going to do is we're going to try one more of these problems. That's right. We're going to try one more of these. I'm going to walk you through it. We're going to do it together. I'm definitely going to use the margin to the left because we are going to be focusing on part A of the try these A. And it's also going to go ahead and look at that same picture that we had before. So what I might do is I might erase some of the tick marks that we put on it so we can kind of walk our way through on how to do this again. and visualize what we're looking at. Now, the proof that we just did that was given to us, right, was 5 steps. We're now going to go ahead and try a 6-step proof. Now, the reason I want you to try to explore this is because your homework for tonight for Miss Graham's class is going to be to try 3 different proofs looking at using our triangle congruence ideas. So I'm going to go ahead and we're going to start looking at, the try these A, part A. So what I need to do is I need to make a 2-column proof where I have my statements on my left and my reasons on my right. So I'm going to say statements and reasons. So what we're going to do is we're going to look at part A and see what the problem is asking us to do. Maybe we have to approach it in a different light. Part A says, suppose that Greg knew instead that LX was perpendicular to JK. Ooh, so let's say he knew that piece of given information instead. And suppose he made measurements to find that, JX was congruent to KX. So we have 2 different givens. Interesting. We're saying, could he prove to his boss that triangle JXL is congruent to triangle KXL? If so, write a proof. If not, explain why. Well, the best thing I like to do is to really actually try to write a proof out of this and see what we can do. So our first reason is always going to be given. All right, but something we can look at is, let's look at the 2 givens. We were given that LX was perpendicular to JK and that JX was congruent to KX. Again, you could start with either given. I think some of you get a little bit nervous when you look at the perpendicular part. You're not sure what that means. So let's stick with that second piece of information that we had, that JX is congruent to KX. So let me start off by writing that down. So let's do JX is congruent to KX. Whoop, let me try that again. And again, we're saying that our reason for this is our given. So I'm going to highlight. You know me, I like to use color. I always think in color, so I'm going to do red for my first step. And I'm also going to label that on my picture. JX is congruent to KX. All right, got it, looking good. Okay, now, since that was a given piece of information and we can't really do anything else with that, let's go ahead onto our second given. It's a little trickier, but we're going to say LX is perpendicular to JK. So that's going to be my second step. So I'm going to go ahead and highlight that. I like color. So think about this. If I know LX is perpendicular to JK, LX is perpendicular to JK, I know that this is going to create, right, kind of that right angle on each of those sides, right? We know we're looking at perpendicular lines. Perpendicular lines create 2 right angles. So wouldn't that be our third step, that we could say angle LXK, what I just marked, and angle LXJ, we could say are right angles. So looking at this, right, that we know that's specifically, not step 4. We're going to look at step 3 still. We know that's definition of perpendicular lines, that if we have 2 lines that are perpendicular, they're going to create right angles. So I'm going to say definition of perpendicular lines. And again, the key word that we're looking at there is perpendicular. So I am going to go ahead, and you know me, I like to highlight, I like to color coordinate, figure out which pieces go together. Awesome. That's looking great. And what I could probably also do is I could mark these on my figure as well. So let's go ahead and mark that these two obviously are perpendicular. Now, I only need to have one of those symbols there, because if I have it on one side, it means that the other side has the exact same thing. So just something to kind of keep in mind as you're working through things. Great. So thinking about this idea, if we know that angle LXK and angle LXJ, if we know both of those are right angles, then don't we know that they're congruent to each other? Right? If they're both right angles, they both have to be congruent to each other. So I'm going to say angle LXK is congruent to angle LXJ. It's going to be step 4. And that's really saying that right angles are congruent. So that's what we're looking at. We know all right angles are congruent. We could even say our right angle congruence theorem. Now, if I know I have this table of definitions, properties, postulates, and theorems, I know some other teachers might have something else that you can work with as well, but I know under my theorems, I have the right angle congruence theorem, what says if angles are right angles, then they are congruent. So just reminding you of that. So it's the right angle congruence theorem. So I'm going to go ahead and highlight that as well. Let's highlight that in green so we can see that those match up with each other. Nice. All right, so obviously now, I could put the right angle there. I could honestly put our congruence marks there. We know that both of those are congruent to each other. So right now, knowing that both of these are congruent to each other, we have a side and we have an angle. So pause the video here. Think about, what do you think would be that last step? Do you think you want to try using side, 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 angle, or angle, side, angle? All right, so this time around, obviously we're not going to use side, side, side. No, that wouldn't really make sense. So we'd probably use one of the following two below since we already have an angle. Think about what we did in our last problem at the green step. Didn't we have the reflexive property? Because LX is on top of LX, right? We know that we could say these are congruent to each other. So we probably want to use side, angle, side. I think that's going to be our best means right here. So we know we could say that LX is congruent to LX, or some of you might like saying LX is congruent to XL. So again, that's going to be our reflexive. Let me try not highlighter. That's going to be our reflexive. Did I spell that right? No, our reflexive. There we go. Our reflexive property. And again, I'm going to go ahead and highlight this in blue so I can kind of see what's going on in our work here, which one matches up to which. Sometimes it might be better for you to use color too. Sometimes that's how our brains just think a little bit better. All right, and then I'm going to go ahead and mark that on my picture as well, which I actually already have marked. Silly me. So now we can see we have that the two triangles will be congruent by side, angle, side. We know that's our reasoning. We can just put SAS. So we know triangle JXL is congruent to triangle KXL. And I just didn't have enough room to write it next to each other. You can go ahead and do that if you do have enough room. And like I said, our reasoning behind this is going to be by side, angle, side. So that proof wasn't too bad to do. We talked about how we would approach it together, what different steps we could go through, what really makes sense. What makes sense with the given information, as well as what do you know from our previous definitions, properties, postulates, and theorems, and how we can go about improving this. So fortunately, we were able to write the proof here. We had enough information to be able to go on to this. So we're at the point of the class where you're going to check in with your teacher on what your homework is for tonight. Miss Graham's class, you can go ahead and turn to the next page, 159. I'm going to tell you what your homework is. So on page 159 for Miss Graham's class, so let me write this down, page 159, I want you to do numbers 8 through 10 for homework tonight. So 8, 9, and 10. So looking at these problems, you can see we have to write a proof for each of them, a 2-column proof. Now, what I'll tell you is to use the 2 examples that we did in class today, the one that Greg did and the one that we did under the Try These 8 together, to help you figure out how you can write your 2-column proof. I was able to do all 3 within 4 or 5 steps. I think that's very manageable. I really want you to take an opportunity to take a risk, pull out your notes, look at the different properties that we've gone through, but also think about what different triangle reasons can we use, right? Can we use side, side, side? Side, angle, side, angle, side, angle. Are there any others could we use? Could we use angle, angle, side? Have we referred back to that? Yeah, it's possible, but I will give you a hint that for each of these, you're going to use side, side, side once. You're going to use side, angle, side once. And you're going to use angle, side, angle once. So that's my little hint to help you on out. Make sure you use the pictures. Put all your congruence tick marks on the angles or on the side lengths, and you'll do great. So have fun and good luck.